AI's real wins beyond the hype cycle. Let's cut through the noise. Yes, AI can write your emails and generate mediocre code. Yes, it's put illustrators and junior programmers in a tough spot. But if that's all you're seeing, you're looking in the wrong places. The genuinely transformative AI work isn't happening in ChatGPT's text box. It's happening in labs, hospitals, and research centers where scientists are using machine learning to crack problems that stumped humanity for decades. Start with AlphaFold 2, DeepMind's protein structure prediction system. In 2020, it solved a 50-year-old grand challenge in biology by predicting how proteins fold from their amino acid sequences with stunning accuracy. The protein databank contained about 190,000 experimentally determined protein structures accumulated over decades. AlphaFold has since predicted structures for over 200 million proteins, essentially mapping the entire protein universe. This isn't incremental progress, it's a phase change. Drug discovery that used to take years of crystallography work now happens in hours. Researchers at the University of California, San Francisco used AlphaFold to identify a new cancer drug candidate in months rather than years. The European Molecular Biology Laboratory reports that AlphaFold has been cited in over 10,000 scientific papers as of 2024, with applications spanning malaria vaccines, plastic-eating enzymes, and crop resilience. Weather forecasting represents another genuine breakthrough. Google DeepMind's GraphCast and similar AI models now outperform traditional physics-based forecasts for medium-range predictions. The European Centre for Medium-Range Weather Forecasts, ECMWF, confirmed in 2023 that GraphCast beats their gold standard model on 90% of atmospheric variables while running 1,000 times faster. When Hurricane Otis rapidly intensified before hitting Acapulco in October 2023, AI models spotted the danger 48 hours earlier than conventional forecasts. That's not just impressive, it's life-saving. The World Meteorological Organization estimates that improved early warnings could prevent 23,000 deaths annually from extreme weather events. AI models run on a single machine in under a minute, democratizing advanced forecasting for countries that can't afford supercomputers. Materials science is experiencing a similar revolution. The Materials Project and similar initiatives use machine learning to predict properties of millions of hypothetical compounds. Researchers at Lawrence Berkeley National Laboratory discovered 18 promising new battery materials in 2023 using AI screening, a process that would have taken decades with traditional methods. Microsoft and Pacific Northwest National Laboratory used AI to identify a new electrolyte material that could reduce lithium use in batteries by up to 70%, moving from 32 million candidates to lab synthesis in 9 months. Traditional materials discovery averages 10 to 20 years from concept to commercialization. AI is compressing that timeline to under 2 years for some applications. Medical diagnostics show perhaps the most immediate real-world impact. AI systems now match or exceed expert radiologists in detecting breast cancer, lung nodules, and diabetic retinopathy. A 2024 study in The Lancet found that an AI system reduced missed breast cancers by 20% compared to single-reader human assessment in the UK's NHS screening program. Google Health's AI detected lung cancer on CT scans, with 5% fewer false positives and 11% fewer false negatives than radiologists. In ophthalmology, AI screening for diabetic retinopathy has been FDA approved since 2018 and deployed in India and Thailand, where it screened over 250,000 patients in underserved areas with no access to specialists. This isn't replacing doctors. It's triaging massive patient loads and catching cases that slip through overworked human systems. The less glamorous but equally important wins come from optimization problems. DeepMind's AI reduced Google's data center cooling costs by 40% in 2016, and similar systems now manage energy grids, traffic flows, and supply chains. The Port of Rotterdam uses AI to optimize container placement and reduce ship turnaround times by 20%. UPS saves 10 million gallons of fuel annually using AI route optimization. These aren't sexy headlines, but they represent billions in efficiency gains and measurable carbon reduction. The International Energy Agency estimates that AI-optimized energy systems could reduce global CO2 emissions by 4% by 2030, equivalent to taking 2.4 billion cars off the road. Now for the reality check. Most of these breakthroughs share common traits. They tackle well-defined problems with massive data sets, clear success metrics, and expert validation. They don't require AI to understand context, culture, or common sense. Protein folding is deterministic physics. Weather is chaotic but governed by known equations. Medical imaging has ground truth from biopsies. These are domains where pattern recognition at superhuman scale creates genuine value. The hype crashes when we expect AI to solve fuzzy human problems like content moderation, hiring decisions, or creative strategy, where success is subjective and data sets are poisoned with bias. But here's where it gets interesting. Once you've conquered the clean, structured data sets, the next frontier is messy, multimodal problems that require connecting disparate data sources. Ocean science is drowning in untapped potential. We have decades of satellite imagery, sonar mapping, temperature sensors, marine biology observations, and shipping traffic data that nobody's properly integrated. AI could predict coral bleaching events, optimize fishing quotas to prevent collapse, track illegal fishing in real time, and model ocean acidification's cascade effects. Woods Hole Oceanographic Institution and Scripps Institution of Oceanography are sitting on petabytes of data that could revolutionize marine conservation if someone built the right models. Archaeological and historical data sets represent another goldmine. Ground-penetrating radar, LiDAR surveys, satellite imagery, and digitized historical records could help AI identify undiscovered archaeological sites, predict where artifacts are likely buried, and reconstruct ancient trade networks. Researchers at the University of Cambridge used machine learning on satellite data to discover 500 previously unknown Mayan settlements in 2023. Scale that approach globally, and we're talking about rewriting human history. The Louvre, British Museum, and Smithsonian have millions of digitized artifacts with inconsistent metadata that AI could organize, revealing patterns in cultural exchange and technological diffusion that humans would never spot. Media archives are hemorrhaging value because nobody can search them properly. The BBC holds 14 million hours of broadcast content dating back to the 1920s. The Associated Press has 25 million historical photos. The New York Times has 170 years of articles, over 15 million pieces. CBS News has 100,000 hours of raw footage from every major event since 1968. Right now, this stuff is essentially locked away because the metadata is garbage, inconsistent across decades, or simply missing. You want to find every time a politician contradicted themselves on camera? Impossible with current search. Want to track how news coverage of immigration evolved since 1950? Good luck manually reviewing 70 years of archives. AI could solve this overnight. Video understanding models can now transcribe speech, identify faces, recognize locations, detect emotions, and tag objects with reasonable accuracy. Applied to broadcast archives, you could search by visual content, not just keywords. Reuters and Getty Images are starting to use AI tagging for new content, but nobody's retrofitted the historical stuff at scale. The value is staggering. Journalists could instantly find relevant B-roll, fact-checkers could verify claims against historical footage, researchers could study media bias evolution quantitatively. Netflix and Disney are already using AI to tag their libraries for better recommendations. News organizations could do the same while preserving journalistic context. The copyright litigation dataset is equally fascinating. Every court filing, every copyright claim, every takedown notice filed with the U.S. Copyright Office since 1790 is theoretically public record. That's 230 years of who claimed what, when, and why. AI could map the entire genealogy of creative works, track how fair use standards evolved, predict which new claims will succeed or fail based on precedent. The Internet Archive is digitizing millions of works that entered public domain, but without AI analysis, we can't efficiently determine what's actually in the public domain versus what rights holders falsely claim. Stanford's copyright renewal database scratched the surface for pre-1964 books, but we need this for music, film, photographs, and software. Social media moderation data represents a darker but essential data set. Facebook removes 20 million pieces of content monthly for violating community standards. YouTube takes down 6 million videos per quarter. Twitter, now X, suspended 1.2 million accounts for terrorism content in 2023 alone. Each decision theoretically has context. What rule was violated, who reported it, what happened on appeal. That data could train genuinely nuanced moderation systems instead of today's blunt instruments that ban breast cancer survivors for medical photos while missing actual harmful content. But platforms treat this as proprietary, preventing independent research into what actually works. Forcing transparency through regulation could enable AI systems that understand context rather than just flagging keywords and skin tones. Urban planning desperately needs this treatment. Cities generate massive data sets from traffic cameras, air quality sensors, crime reports, property records, utility usage, and demographic shifts. But nobody's built systems that integrate all this data to optimize zoning, predict gentrification, or allocate social services. Barcelona's Superblocks project used limited AI optimization and reduced traffic accidents by 27% while increasing green space. Imagine applying that citywide across hundreds of variables. Singapore's Virtual Singapore project is attempting this, but most cities lack the technical capacity. The data set exists, the political will is what's missing. Ecosystem modeling could prevent the next pandemic. We have genomic databases, animal migration patterns, climate data, deforestation rates, and disease outbreak histories. AI models that integrate these could predict zoonotic spillover events before they happen. EcoHealth Alliance and the Global Virome Project are sequencing viruses in wildlife, but the predictive models that could connect viral evolution to environmental changes and human encroachment barely exist. The COVID-19 pandemic cost $16 trillion globally. Spending $10 billion on AI-powered pandemic prediction would be the bargain of the century. The agricultural revolution is just starting. Farmers generate enormous data sets from soil sensors, satellite imagery, weather patterns, crop genetics, and pest populations. But current AI applications are primitive. We could optimize crop rotation at field-level precision, predict pest outbreaks weeks earlier, breed climate-resilient varieties in half the time, and reduce fertilizer use by 40% while increasing yields. The UN Food and Agriculture Organization estimates we need to increase food production by 70% by 2050 to feed 10 billion people. AI working with agricultural data sets could actually make that possible without destroying what's left of our topsoil and aquifers.